Okay, so we're going to start on the last section from chapter 6 that we're going to cover, and it'll be, there's a little bit in there that we're not going to cover, so the main focus will be on phase shifts and using this to graph. It's just another way to do it, just like with transformations or anything like that, instead of necessarily always strictly going on the 5 key x values, which we'll still do. You can kind of, I guess, keep track of things, so I might switch it up and do it a slight different way. The main thing is they're gonna, for sine and cosine, we're gonna have something like this, right? Also for cosine, we have y equals a cosine omega x minus d plus b. Now your book uses phi instead of d, but it's so hard to write, I'm just gonna use d, okay? So what we know so far is we know that the amplitude is the absolute value of a, the number in front of the sine. We know that the period for sine and cosine is 2 pi divided by omega. And we know that the vertical shift is the plus b or the minus b, whatever it is. You go up 1 or down 3 or whatever. We now are going to bring something else into the fold, and we're going to talk about a phase shift, or it's basically a horizontal shift. Okay, so the main thing I want you guys to realize with this problem is if you want to find the phase shift, you have to factor omega out. So we're going to rewrite this as y equals 3 times the sine, and then you do this, 2 times x minus pi over 2. Now, if you don't believe this is correct, what's 2 times x? If I distribute 2 times x, we'll get 2x. If I distribute 2 times negative pi over 2, I'll get minus pi, which is the same as what I started with, right? So the reason you want this is this shows you what omega is. I'm sorry, not what omega is. This shows you what the phase shift is. So right here, this is now the phase shift. So what you could do then, if you know this information, you could take your graph, and let's say that you knew this function, you knew the original 3 sine x function. You now, or the 3 sine of 2x function, you now could build a phase shift and just take all of those values and move them to the right a little. I still personally believe that it's kind of nice to still build the 5-number sum, or not the 5-number summary, that's statistics, to build the 5 key x values and then build your table, which we can still do. But what they want you to kind of see is let's go through the period. So we know our amplitude is worth 3. We know that our period is worth 2 pi divided by omega, right? And omega was 2, so we have pi. We know our interval size. You see how everything's still the same. Interval size equals pi divided by 4, right? So then if I wanted, I could graph this just like normal, but there's a problem, is I have 3 sine of 2x minus pi, okay? 1, 2, 3, 4, 5. Now here's the rub. Where does the sine function normally start at? When we normally draw sine, we normally start it at 0, right? So what I'm going to do is I am going to just put like right here and here, right? So this would normally be 0, and then because the period is pi, this would be pi, right? And that would be good. And then I would go and I would cut this, right? And I would do that. However, we're going to try to use the phase shift to do this. So what I'm going to say is that if this was where I would normally start and this is where I would normally end, I have a phase shift now. Phase shift of pi halves to the right. So you always take the opposite sign of whatever's in there. So, and remember, this is your omega, this is your d, this is your a, and there is no b, plus b, there's no b, okay, for this particular problem. So here's the thing. If I was supposed to end at pi, okay, and I have a phase shift of pi halves to the right, that means I actually am now supposed to end at, let's do it right here. So suppose I was supposed to end right here at pi. Well, I'm not going to end at pi anymore. I'm going to phase shift to the right pi halves. So that means I'm going to take pi plus pi halves. So that would be what? Pi, which is 2 pi halves, plus pi halves. So that'd be 3 pi halves, right? So I'm just going to go over here, 3 pi halves. Okay. And I was supposed to start at 0, but I have to shift to the right pi halves. So I'm going to go right here to pi halves, right? And now I'm going to do my little cutting right there. So I'm no longer starting at 0 anymore. So now my first x value is going to be pi halves. Now I'm going to add a pi fourths to that. Or you could do it a bunch of ways. You could take, these two guys and add them up and then divide by 2, and you'll find the midpoint. So pi halves plus 3 pi halves would be 4 pi halves, which would be 2 pi. And then divide that by 2, you would get pi. So we know this is pi. And then if we want, we could take this guy and this guy. You can do it all kinds of ways. I'm just going to take pi halves plus another pi fourths. So that would be 3 pi fourths. Then I'm going to add another pi fourths to that. I'm going to get pi. Then I'm going to add another pi fourths to that. I'm going to get 5 pi over 4. And if I add another pi fourths to that, I'm going to get 6 pi over 4, which is 3 pi halves, which is where we were supposed to stop. So this actually worked, right? Now I know that I have an amplitude of 3. So I'm going to go up 1, 2, 3. I'm going to go down 1, 2, 3. Okay, so this is 3 and this is -3. Now, because there's no vertical shift, I know that the normal sine function, normally sine starts at 0, right? I should say a height of 0. So what I'm going to do is I'm going to still start at a height of 0, but right here. Then I know that it goes up to 1, but instead we're going to go up to 3 because we have an amplitude of 3. Then I know it comes back down to 0. Then I know it goes down to -1, but in our case, -3, and then it comes back up. So we have this, and that's our graph. So I already know the graph before I've even done anything. But what I'm going to do is I'm going to double check it with my 5-number summary, or I keep saying the 5-number summary, with my 5 key x values. So when I put pi halves into here, right, or into here, when I put pi halves into there, that becomes 2 times pi halves, which is pi, and pi minus pi is 0. Sine of 0 is 0, okay? 3 pi fourths, let's see, 3 pi fourths times 2 would be 3 pi halves, and the sine of 3 pi halves, wait a minute, that's 3 pi halves minus pi. So that's pi halves, and the sine of pi halves is 1, times 3 is 3. Now I'm going to put a pi in there. 2 pi minus pi is pi. Sine of pi is 0. 5 pi fourths times 2 would be 5 pi halves. That would be 1 times, oh no, wait, 5 pi halves, 3 pi halves, 4 pi halves, 5 pi halves. Let me see here. Maybe I'm doing that one. 5 pi fourths times 2 would be 10 pi fourths, or 5 pi halves. And then 5, oh, there you go. I forgot to subtract pi. 5 pi halves minus pi would be 3 pi halves, and the sine of 3 pi halves is -1. -1 times 3 is -3. And then 3 pi halves times 2 would be 3 pi, would be minus pi, would be 2 pi. So the sine of 2 pi is 0. So now if we go and graph these points right here, right? If I go and graph these, I get pi halves 0. I get 3 pi fourths. This is 3 pi over 4, and this is 5 pi over 4. 3 pi fourths is 3, there, there, and there. So I knew it was already going to happen. So that's how knowing how to use a phase shift is better than necessarily having to do the 5 key values, okay? The phase shift can really help. So if you can identify the phase shift very quickly, it can kind of save you a lot of work, okay? Let's look at another one. Let's do a cosine this time. So this is another one from your book. So this is y equals 2 cosine of 4x plus 3 pi, okay? So now here's the thing. we have to write it in the better form. So this is going to be 2 cosine of 4 times x plus 3 pi over 4. So you factor a 4 out. And once again, how do I know I'm right? If I distribute that 4 back in, I'm going to get 4x plus 3 pi, which is exactly right. So my phase shift is negative 3 pi over 4, or 3 pi over 4 to the left. Because it's a plus, we take the opposite sign. Okay, so we're going to take our graph. Oops, that's really bad. Okay, and I'm going to go up 1, 2, go up 1, 2, or down 1, down 2. Now here's the thing, where does cosine normally start? Cosine normally starts at 0, right? It has a x value of 0. That's where we normally like to start it. You could start it anywhere. It's kind of a loaded question. You could actually start it anywhere if you felt like it. But when we draw our graph, we normally try to stay from 0 to 2 pi and then go from there. So let's shift it over 3 pi fourths. So let's say that this is negative 3 pi over 4. So I have a phase shift. Three pi over 4 left. I have an amplitude equal to 2. I have a period equal to 2 pi divided by 4 of pi over 2. Is that right? Let's see here. My omega was 4. Yeah, so I got to divide my period 2 pi by 4, so I get pi halves. Then my interval size is going to be pi over 2 times 1/4, or divided by 4, which is pi over 8. Now, if you want, we know we're going to start here, right? We know we're going to start here. If you want, what you can do is you can just add 1 period to negative 3 pi over 4. So if I take negative 3 pi over 4 and I add a period of pi over 2, that would be what? Negative 3 pi over 4 plus 2 pi over 4. So that would be, ooh, I didn't leave myself very much room. Let's do this, negative 3 pi over 4. And we now know that we're going to end at negative pi over 4. That's not very far, right? That's negative pi over 4. So now when we cut that in half, cut that in half, and cut that in half, we kind of know what we're getting ourselves into. We know that normally the cosine function starts at 1, right? It starts at 0x and it has a height of 1. But in this case, because we have a amplitude of 2, our height won't start at 1, it'll start at 2. So negative 3 pi fourths, I'm going to put up here at 2. Maybe I'm wrong. I just want to kind of guess to see if I'm getting the hang of this, right? Now I know the next value is going to be pi eighths bigger than 3 pi fourths. So some of this you might not be able to do in your head anymore. This is getting kind of out of hand. Negative 3 pi over 4 plus a pi eighths. So that's actually negative 6 pi over 8 plus pi over 8 would be negative 5 pi over 8. So this would be right here, negative 5 pi over 8. Then if we added another pi over 8 to that, so we do negative 5 pi over 8, and we add a pi over 8, that will be negative 4 pi over 4, so that'd be negative pi over 2. Right, you guys see what I'm doing? I'm just trying to build these values here. So this will be negative pi over 2. Now if I add another pi over 4, or pi over 8 to that, that will be negative pi over 2 plus another pi over 8, and I'm getting this from my interval size. So then that would be negative pi over 8. That'd be 4, so it'd be negative 3. Oops, negative 3 pi over 8. So this is negative 3 pi over 8. And then if you add another one to that, you get 2 pi over 8, which is pi fourths. So before I do anything, I'm just now going to go, I know how the cosine function behaves. It's going to go here, then it's going to go here, then it's going to go here, then it's going to go here. And that's my graph. But if you guys want, you could build your little table, right? And you have your x, and then you have your 2 cosine of 4x, 2 cosine of 4x plus 3 pi, and then go 1, 2, 3, 4, 5. Okay, and then you would just go from there and you plug in your values, negative 3 pi over 4, add an eighth to that, you get negative 5 pi over 8, add an eighth to that, you get negative pi over 2, add an eighth to that. Sorry, you guys, I'm losing my voice a little bit. I think negative 3 pi over 8, and then negative pi over 4. So this is an alternate way to do it using the phase shift. You just kind of think of where the original started. Did it start at a height of 1, or did it start at a height of 0? Did it start as an x value of 0? When you're talking sine and cosine, normally you do. And then I just went from there. Okay, so this is definitely, so when I plug this in, I would get 2. When I plug that in, I would get 0, 0, 2, and this would be negative 2. So this is another way you can work these problems. And notice I answered everything. I got a phase shift, I got my amplitude, I got my period, I got my interval size, I got my 5, and I got my graph, right? So you can do a lot with the phase shift. You still have to know a lot of information, but the key to the phase shift is omega. You got to factor this out. That's the #1 mistake I see people make. Okay, you must factor out omega. All right, let's see if I got another one in here. Let's see. Do they have one for tangent or cotangent with a? I don't think they do that as often. Yeah, there's not that many of those. Let me see if I have another one in my notes. Let's try this one. Okay, so let's take a look at a nicer one. Y equals tangent x over 2 plus pi. Okay. So I told you guys that if you want to talk about the phase shift, you have to do y equals, and then tangent, you have to pull that 1/2 out. And when I pull the 1/2 out, that's going to leave me with x plus, now I need to end up with pi. So I'm going to say 2 pi, right? So if I say 2 pi and I distributed, I get 1/2 x plus pi, which is the same. So again, they don't do, let me see here. Yeah, they don't normally do phase shifts with tangent as much, but it does still work the same. The reason it is kind of weird is because you're shifting around the x-intercepts and you're shifting around the asymptotes. So we just kind of got to be careful. I actually don't like using this method with tangent. I would rather just draw my table. So maybe I'll just teach you guys that. That's a little bit better for you. But again, it works the same. I've just seen it. It can go sometimes wrong with the tangent, because in a way you have to check everything anyway. Okay, so tangent doesn't really have amplitude, right? We have our omega is equal to 1/2. So then our period is equal to pi divided by 1/2, which is the same as 2 pi. So that's why it's kind of weird. You'll see in a second. So normally we start here at negative pi over 2 and pi over 2, and then we have an x-intercept here, right? But the problem is that that would be if the period was pi, And that would also be if we didn't have a shift. So what I would like to do is I would like to find my x-intercept first, okay? So this just helps me in general. X-intercepts are whenever the tangent function, whenever the cosine function is 0. So the cosine function would be 0 whenever you get 3 pi halves, pi halves. So what I'm going to do is I'm going to take x over 2 plus pi, and I'm going to set it equal to pi halves. Okay, because that's when cosine would be a problem. That's when it normally is, right? So now we can take into account x, I'm just going to multiply everything by 2. So this would become x plus 2 pi equals pi. Subtract 2 pi, subtract 2 pi. So x equals negative pi. Okay, so to me, did I say that was an x-intercept? No, this is not the x-intercept. I should have done when sine is 0. So this is asymptotes. Sorry about that. Please erase that. I'm getting tired. I've been doing too many videos today. Sorry about that. So vertical asymptote is whenever the cosine function is 0. Okay, and that would be at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, so on and so on and so on. Okay, so our first one will be at negative pi. So that means that this is actually now negative pi. And then what is our period is 2 pi. So then that means this should be pi, because if we calculate this distance, that is a distance of 2 pi. So I'm feeling pretty good that those are my asymptotes. And once again, I know a lot about this because I've done the tangent function before, so I know it's normally pi halves and negative pi halves. This time it's negative pi and x equals positive pi. These are my vertical asymptotes. Now I need to find my x-intercept, which I mistakenly was doing last time. So you set x over 2 plus pi equal to 0, because that's when sine is equal to 0, and that's when you would get an x-intercept. Because remember, tangent x is sine x over cosine x. So if you're trying to find asymptotes, you worry about cosine. If you're trying to find x-intercepts, you worry about sine. So x-intercepts, we're worried about when sine would be 0, because that would make the fraction 0. So we're going to come up here, and this would be, I'm going to multiply by 2 again. So this would just be x plus 2 pi equals 0. So x equals negative 2 pi. Okay. So that means there's an x-intercept at negative 2 pi. But then if you add 2 pi to that, you get another one at 0, and then another one at pi. So now I kind of already know what my graph looks like. There's no negatives, right, or anything like that? Nope. So it's going to be something like this. And then we're going to do another one like this. And then we're going to say there's another asymptote here somewhere. Okay. And that's basically how you do it. For me personally, I don't like the phase shift method per se. I just like finding x-intercepts and my asymptotes. That's kind of my way to go with tangent functions, because I've seen students kind of go wrong with the phase shift. It doesn't quite work how they want. So according to this, our phase shift should have been, let's see here, 2 pi to the right, which it turns out that would have worked. That would have been okay for this one. I've just seen it go a little bit downhill on certain problems when there's more going on, like with vertical shifts and phase shifts and stuff like that. So hopefully that helps you guys with that one. But again, most of the time when you're doing those, you're doing sine and cosine. Every once in a while it'll be a tangent, but tangent just is a little bit harder overall to get values to be super clean and nice. But let me know if you have any questions about this. I think I'm going to end the video. How many did we do? We did 3. I don't think there's very much homework for any of these sections. Yeah, so the big thing about this is trying to see how much faster I can do it if I just kind of have memorized what the sine and cosine function are supposed to do, and then I just move it around and shift it, change the amplitude, vertical shift it, whatever. I can take care of any of that. So go ahead and get started on the homework. Hopefully this helps you guys get through this.